Hello, hello, and welcome to our very last unit for credit and content recovery. We are on Unit 10, Similarities. So, a lot of these questions are already done for you, so I'm going to do a lot of explaining. Remember, as usual, some of the questions will be just like the ones in your test, but some of them will be, of course, different, but they all will be similar. So, let's go ahead and get started. If my gray function is my original shape or function, when you have nice, beautiful whole numbers like this one, and all we're doing is growing it with the scale factor of 2, I'm going to just plot really quickly all of these locations. 3, 2, oopsie, 3, 2. All you're going to do is double it. That's it. All you're going to do is double the size because it's being rotated about the, or I'm sorry, it's being transformed about the origin. So there's not going to be very much that you need to do to it. So if you notice, like this first 1, 2 is now going to be 2, 4. This was 3, 2. Now it's going to be 6, 4. This was 3, -1. Now it's going to be 6, -2. Okay, that's it. So you're just going to double them and make sure that their growth, that they grow with the scale factor of 2. With the scale factor of 3, you would be multiplying by 3. So we're multiplying by 2. The next question, the very next one, says to shrink your function by 1/2. And it can get a little wonky when you're shrinking functions by 1/2, especially if you have odd numbers, because then you're dealing with decimals. But for this one, so for -4, 4, if I just take that by 1/2, that's just going to be -2, 2. Okay. Let's do another one. This one right here, nice, easy whole number, 6, 8. We're going to shrink that right here to 3, 4. We should not be doing any that are not about the origin. I'm going to keep this pretty simple for you all. 2, 2, shrink it in half. It's just going to be 1, 1. Okay? So your new locations are just half the size, and because they're even, it should be pretty straightforward for you. I know sometimes it can get a little bit confusing. Okay? And that's the same thing for the last one. Now this one is a little bit different, and that's why they want you to use your polygon tool to help you graph this, because this one you're going to graph the figure after a dilation of a scale factor of 2, centered at -3, 1. So notice that this point right here is -3, 1. Okay? I went ahead and plot this point. This is my original function right here, this triangle that's in gray. It was at -3, 3. It would be at -6, 6. But it's going to be centered at -3, 1. So I have to keep that in mind. This one, and then from here, what I like to do, and I know this might be a little bit of a cheat, but don't tell anybody. I can go 1 up and then 1, 2, 3, 4 over. My growth should be 2 up and then 1, 2, 3, 4, 5, 6, 7, 8. So my distance between my points should double. If I'm doing it right, my distance between my original points, which was 1 and 4, are now 2 and 8. And I'm going to do the same thing for all 3 points. All right. Let's go to the next question on similar triangles. Oopsie. Gotta charge my tablet. Complete the similarity statement for the 2 triangles. Now remember, with similar triangles, With similar triangles, I'm right here on this question. I don't know why these are so close to each other, but it's weirding me out. With similar triangles, the order is going to be the same. So I'm looking for, even though the side measurements aren't the same, you're not looking at the sides, S-I-D-E-S. No. Sides are proportionate. Angles are congruent. Sides are proportionate. Angles are congruent. So I'm going to zoom into this a little bit so that you can see exactly what I'm looking at over here. I'm looking at angle B corresponds with angle N. Looking at the angles. Angle X corresponds as 1, 2, 3 markings with Y. And then last but not least, R corresponds to J. And that's just like when we did congruency markings, the order matters. The order matters. So you have to put X and Y together. So it has to go triangle Y. And then B is next, so N. And then J. Y and J. Triangle DEF and is similar to triangle RST. So let's look at the corresponding parts. Just like congruences, just like congruencies. If you were to label these with colors like 1, whatever you want to do, 2, 2, DEF, RST, and then the last one, F is 3. Oopsie. F is 3, T is 3. There it's going to correspond. So E is going to be with S. E is going to be with angle S. Angle D is going to be with angle R. DF is the first and last letters. DF is the first and the last letters. So that's going to be RT. They're not congruent, they just correspond. That means they're in the same location. And then EF is going to correspond to ST. Correspond does not mean congruent, that just corresponds just means same location. All right, number 6. It is important when you're doing your similarity statements that you align things that correspond. You just can't put them in any order. The order does matter. Okay? If you have to highlight, you all should know by now how to do a screenshot. A has 1 marking, so I can look for R has 1 marking. Highlight things, whatever you have to do to make it a little bit obvious for you. B has 2 markings, Q has 2 markings. C has 1, 2, 3 markings, so does P. And then, of course, the last one's S. Which triangles could not be similar to triangles ABC? Well, similar triangles have congruent angles and proportionate sides. So when I'm looking at my options here on the right, they're all right triangles, but do they all have the same proportions and sides? Do they all have similar proportions in size? Remember, we're looking for the ones that are not. So an easy way is like, these were all multiplied by 11. So these are this one's similar. Because it's just multiplied by 11. All 3 sides. All 3 sides on this one for this last, on this right here, are multiplied by 2.5. So these are similar. Remember, you can do a calculator. You can do like 10 is to 4 is to 10. As 5 is to 12.5. All of those ratios should be the same. When I get to this one, I notice that if you notice right here, if I look at 4 times 6 gives me 24. 5 times 6, this should be 30. 3 times 6, that should be 18. So that's no good. So that works. This one right here, it doesn't even make sense. 4 and 21, 5 and 29, and 3 and 20, the ratios just aren't the same. And then, of course, I have to put in my calculator and see. All right, let's go to the next one. Now you're doing quadrilaterals. It's the same thing. If they are similar, then they will have, the ratios will be the same. Okay? So in your calculator, you should be able to do 40 is to 8 as 15 is to 3. Notice that both of these are 5. 18 is to 4.5 as 6 is to 1.5. Both of these are 4. Okay. You cannot do that for these other two. 1,225 is to 3.5. Nope, as 144 is to 1.2. Okay. And then we have the last one. 13 is to 5.2. Nope, as 5 is to 2.5. That's not, those are not true statements. You can, of course, put those in your calculator. You have that little calculator app that you can use. Which pairs of rectangles are similar? Remember, similar, we're looking for proportionate sides. Proportionate sides. So with my calculator, I'm comparing 105 to 120, right? And I'm going to see if it's equal to, so 105, maybe I'll change this color so you all can see what I'm doing. 105 to 120, and I'm seeing if it's equal to 80 over 90. So in my calculator, that's what I'm doing. And I get two totally different ratios. I get 8 over 9, and then for the other one, 7 over 8. So for this one, I get 7 over 8. And this one, I get 8 over 9. So that doesn't work. Now let me do A and C. So I go 105 to 100. And I want to compare that to 80 and 75. So get my handy dandy calculator. And I get 21 over 20. So A is C, I get 21 over 20 and 16 over 5. I'm sorry, over 15. Okay, so A and C. So this was this is C right here. I made C blue. I mean teal or green. And then, so now I can try B and C. 120 and 90, and I want to compare that to 100 and 75. And I get, you hear my calculator ticking away in the background there because I'm using it, 6 over 5 for both. So 6 over 5 is equal to 6 over 5. And that's how they determine which ones are similar. So these are not similar because their proportions are not the same. The B and C are similar because their proportions are the same. Oh my gosh, y'all. That is it. We are done with Unit 9, Geometry. Good luck. I hope you all passed all your units so that you may go on to your next class. Bye.